So we're going to look at our first example of modelling using parametric equations. It's part 8.5 in the textbook, and we're going to look at example 11 from the textbook. So let's have a read through of it. A plane's position at time t seconds after takeoff can be modelled with the following parametric equations. X is equal to v cos theta t meters, and y is v sin theta t meters, where t is greater than 0. Also told v is the speed of the plane, theta is the angle of elevation of its path, and x is the horizontal distance travelled, and y is the vertical distance travelled, relative to a fixed origin. When the plane has travelled 600 metres horizontally, it has climbed 120 metres. Now, for just like all videos you're watching, what I really recommend is just pausing, having a go, thinking about at least what you would do for each section before you click play again. So you might want to have a quick think about what you would do for finding that angle of elevation, and clicking play. You've hopefully, and well done if you just noticed that this is just actually a right angle triangle where I've got an opposite of 120 and adjacent of 600. So I'm just going to be able to do my SOHCAHTOA TOA. So tan of the opposite 120 over the adjacent 600 would give my angle of elevation. So I do my inverse tan of that. I get that my angle of elevation is 11.3 degrees. And I've found one of my values. Given that the plane speed is 50 meters per second, find the parametric equations of the plane's motion. Right, what are parametric equations? Well, parametric equations, this whole chapter actually, this whole section of the chapter is about how parametric equations are useful for modelling situations like this, where you want to you've got a reliable model for one variable like distance, and a reliable model for another variable like height, and you want to model those separately and also hopefully ultimately perhaps bring those two together. If we're trying to find the parametric equations of the plane's motion, what have we been given and what have we got now? Well, we've been given that the speed v is 50, and we've just figured out that the angle of elevation is 11.3 degrees from the previous question. So substituting those in to what we know x and y to be, we can express that our x is 49.0 t meters to three significant figures, and our y is 9.80 t meters to three significant figures. And now, because we've got equations for x and for y both in terms of t, we've got our parametric equations for those two. Show that the plane's motion is a straight line. This is less obvious what you're asked to do here, but this actually goes back to the beginning of the chapter where we're actually trying to just express these two variables in Cartesian form, because what do we know about straight lines? We know y equals mx plus c, or y minus y1 equals m brackets x minus x1. So if we can express it in either of those two forms, we can show that we've got a linear equation here. Have a go at doing that. And clicking play. You know your x is equal to 49t, so t is x over 49, and then as you have an expression for y in terms of t, you could then substitute that expression for t in to get y equals a fifth x, so y is equal to a fifth x, which is a linear equation. Realised after I said that we'd skipped over part C, so find the vertical height of the plane after 10 seconds, pause, have a think, have a go, and then click play. Well, you were right if you recognise, well, y I'm told was the elevation, the vertical distance travelled, so the height of the plane. So I can substitute 10 into my expression for y now, which I've got nice and simply in terms of t, and doing so I get 98 metres. And finally, often a very common question at the end of all of these, where it asks you to just challenge the model, consider the model for its any issues that there are with it. Explain why the domain of t being greater than 0 is not realistic. Well, what are the main problems here? Try and actually verbalise it as a sentence out loud, and then click play. Well, the problem is that we've found that y is equal to a fifth x, so effectively we've got this plane carrying on elevating and rising forever. That of course is not realistic, because we want our planes to come down eventually. So expressing a sentence which showed an understanding like that was what you had to do for the last part of that question.